Now let's take another problem. This example says a box slides across a rough surface. If the coefficient of friction is 0.3, what is the acceleration of the block? And part B says, given the acceleration of the block sliding across the rough surface is minus 2.94 meters per second squared, if the initial speed of the block is 10 meters per second, how long does it take for the block to come to rest? So in this case, what we will have is a block that's sitting on a rough surface, and the coefficient of kinetic friction between it, let's say the motion is this way, so the coefficient of mu k is 0.3. Okay, what it's asking us, what is the acceleration of the block? Okay, so we have to find the acceleration of the block. How fast is it moving? So this is m. Interestingly, it doesn't give me an m, it doesn't give me anything, and I'm expected to find what the acceleration is by pretty much nothing. Actually, it's possible to do this. How do we do that? Well, as always, we are going to start with sigma fx and sigma fy. Okay? I know normal exists and mg is always going to be there. Okay? So n minus mg, I have no problem writing. Okay? Now, there is a force of x here. Is there an applied force? The question tells me no. So the only force that's really acting on it right now is friction. So I'm going to write Fs here. And I know that this object is accelerating. That means this is going to be equals to ma, right? Okay, so from my equation number 1, I can write ma equals static friction, right? With a minus sign because it's moving towards the minus sign. And I've chosen my coordinates x and y. Just normal ones. Okay? From equation 2, since there is no motion along the y-axis, I can simply write n equals mg. Now, what do I know about Fs? I know frictional force is equals to mu times n. So from equation number 2, I can rewrite this expression as ma equals minus mu mg, since this was equals to mg from equation 2. Okay? So m's go away. What am I left with? I am left with a equals minus mu g. Okay? Mu is given to us, which is 0.3, 0.3, and I know the value of g is 9.8. So I can plug the values in here, and what do I get? Meters per second squared. I get minus 2.9 meters per second squared. Okay? So by just giving me one single unit, no mass is given, no acceleration is given, no forces is given, the question tells me what direction to go. As long as I can write these force equations, I can solve these problems. Okay? Now for part B, it's saying that take this acceleration that you found, and given that your initial speed is 10 meters per second, so this is part B, 10 meters per second. How long does it take for the box to come to rest? So delta t is what I'm looking at, what I'm looking for. Now, in this case, we will go back to what we learned in equations of motion. What do we know about equations of motions? Okay, I want to find delta t. I have an acceleration. I have an initial velocity. Also, note the words very carefully. It's saying for the box to come to rest. So that means my final velocity has to be 0. Yes, absolutely, because it has to come to rest. So knowing all of this information, I can rewrite VF. Equation number 1 might be a good equation to use. VF equals V naught plus AT, which means VF was 0. This is 10 minus 2.94 right? And t is what I'm looking for. To move things around, I'll get a minus 10 equals minus 2.94 t, and you can solve for t, which comes out to be equals to something like 3.4 seconds. So this whole entire question was solved by actually just having one number, and that was just this number. Everything else we were able to pick up from the wording given in the question.